let's go on with our exponential functions and the graphs. We're going to use a one-to-one property to solve for each equation. So let's go back to here. For a is greater than 1 and a not equal to 1, a of x equals a to the y if and only if x equals y. So let me give you an example. If you have 5 raised to the x equals 5 to the 10th, the one-to-one property states that our exponents are equal, x equals 10. Now, the most important thing to note is that you must have the same base. Okay, so that's what this property is stating. So let's try that in example 4. We have 9 equals 3 raised to the x plus 1. So they are not the same base, but we can make it so. 9 we can change to 3 squared, and then now this is 3 to the x plus 1. So now it's the same. So we can say 2 equals x plus 1 and then solve for x. So in this case, x equals 1. For example B, it's close again. We have 1 half raised to the x equals 8. So 1 half, we can write that as 2 to the negative 1, and then we multiply it times the exponent of x, and that equals 8. Well, we could change that to 2 cubed. Now the exponents are equal, so we have negative x equals 3, or x equals negative 3. So I want you to go ahead and try this example up here. Use a one-to-one property to solve for the equation for x. So pause the video and try it out. So if you tried this out, you would have gotten 2 for letter A, and letter B, you would get a positive 3. So remember, negative times a negative is a positive. So this next part, we just want to talk about transformations of graphs of exponential functions. So we're describing the transformation of the graph of f of x equals 3 raised to the x. And so we can take a look at the graph, but I think we should just focus on the equation. That's faster. Sorry, that's the equation there, and here, and here. So we have x plus 1. It is with the x. The transformation is with the with the x. And then we also notice that it moves here. So we notice that this is left 1. So when it's with the x, it's a horizontal translation, and this is left 1. So here we have 3 to the x, and then minus 2 on the outside. And so we can say this is down 2. For the next example, letter C, we see that it's flipped over. So this is, and we see that the negative is in front. So this is a reflection in the x-axis. For letter D, we see that we have a negative with the x, and it's flipped over. It's flipped over the y-axis. So this is a reflection in the y-axis. So try out these examples real quick. Just describe the transformation of each. Pause the video, and when you come back, I'll have the answers for you. So if you tried this out, this one is right 2 for letter A, B is up 3, and letter C is reflection over the y-axis and down 3. Let's take a look at the natural base E. So natural base E, in many applications, the most convenient choice for a base is the irrational number E, which is approximately 2.718281828, and goes on forever. This number is called the natural base. The function f of x equals e to the x is a natural exponential function. Note that e is a constant, 2.718281828, where x is the variable. Okay, so here's a variable x. So, and here's the graph to the right. What we're going to do is use a calculator to evaluate the function f of x equals e to the x at each value of x. So what you're going to do is on that TI30x2s, in order to get to the e to the x, you actually press second, and then you press ln, which does get you to the e to the x if you see it at the top. And then it'll automatically do the exponent for you. So then once you do that, you type in that negative, the one with the parentheses around it, and then the 2, and then enter, and then that should get you your answer. So in this case, you get 0.13533353. So go 7 decimal places. Try out letter B, C, and D, and then when you come back, I'll have the answer for you. If you tried it out, you would have gotten these: 0.3678794, 1.2840254, and 0.7408182. So now that we know how to plug it into a calculator, we're going to graph natural exponential functions. So sketch the graph of each natural exponential function. For me, I'm just going to ask you for 3 points. So let's choose 3 points. Well, one of them you should choose is 0. If I plug in 0 here, that means it's e to the 0. E to the 0 is just 1. So 2 times 1 is 2. So here's the point here. Then the next point you would probably choose is a positive 1. So 2e raised to the 0.24. I mean, you could go 2 decimal places. It's, you're just needing to sketch the graph here. And so you would get approximately 2.54. And then if you say 2e to the negative 1, which is negative 0.24, then you would get approximately 1.57. So then we'll graph that. So 2.54 is around here. 1.57 is about there. And then so we know that it's a growth function. So you can go ahead and try letter B and C. And when you come back, I'll have the graphs for you. So if you tried it out, I just rounded to 2 decimal places to the hundredths place. This is what your graphs would look like. Okay, so I hope this helps. Thanks for watching.